What are you doing over there? Alright. Let me do it like that. If I had 0.9%. If I had 0.9%, how would you write that as a decimal first off? Yeah, you got to move the decimal back how many places?
Twice.
Once, twice. So it'll be 009. Is that cool? Once, twice. Once, twice. Yes, ma'am?
Is that because when it's red it's, oh wait, it's red is 9 thousandths, right?
Well, now it is.
Yeah.
Cool. I like that. And that's the answer to the fractional part, right? That's tenths, hundredths, thousandths. So 9 thousandths.
Is it always going to be thousands if there's a decimal there as a percentage?
I would highly suggest you not try to memorize things like that. That's just mixed. And that's what some people believe math is. And I'm not saying you do. I know you're trying to look for patterns and stuff. But you just, wherever the hell it is. Hella. Move that decimal back twice. And once it's written as a decimal, it's easy to get to a fraction. Please, dear God, we got to be at the point where we know these places. Right, tenths, hundredths, thousandths. So what if I had 0.003%? How would I write that as a decimal? This is where your brain doesn't like what you got to do, but you do it because that's the way you do it. No? See, your brain didn't like what you had to do, so you went the other way. I've got to go the same way as always. I've got to move it back once, twice.
It's always that.
So now there were 2 zeros there, right? And that was going to be 1, 2 more zeros. Oh boy. Because it's such a small freaking percentage, it's going to be an even smaller decimal. So I know that a part of our brain says, that's small already. That poor little number. It's so tiny. Let's make it 0.3. That poor little... No, it's small. Let it be small. Right? It accepts its smallness. It says, I am small. I don't care. That's how it sounds. Now, what place is this in? This is tenths, hundredths, thousands, 10,000, 100,000. So it's so much easier to go from decimal to fraction. Now, when you have a decimal in a percentage, screw that. Let me go to decimal, full decimal, and then I can go to fraction, no problem. And that's the number you put on the bottom, whatever place it's in. I like it. Right? Yeah, so that's in the 100,000s place. So put 100,000s on the bottom. Kick ass. Okay. I don't know. Remember how you could do 0.9 over 100? What was wrong with 0.9 over 100? You guys see why I can do that, but I'm not done? Percent means out of 100. So for anybody worried about, well, now you're doing something different, Jeff. No, I ain't. Because if I got to move the top over once, I got to move the bottom over once, 9 thousandths, holy shit. If I do it with this guy, it's going to kind of suck a little bit, but oh well. That's 0.003 over 100, right? I got to move this over 1, 2, 3. Got to move this over 1, 2, 3. There you go. 3 over 100,000. Same thing. Same. Dang. So there's 2 different ways to do it. This way it gets a little bit easy to get confused and make a mistake. So I would highly suggest go here and then go there. It's like David said, it's just a matter of seeing what place it's in. All right, how are we doing there? Is that cool? Anything else from the quiz or from homework? Are you guys doing the homework?
No. A little bit.
Well, honesty is always nice.
Right.
But doing the homework would be even better.
Let's try.
Oh, sweet. Look at that. Lydia's like, here, math boy, shut up. I got homework. Make you feel so good. All right. So there's no other questions from homework or the quiz. We're going to finish out chapter 6. You all right? You look so worried. Thank you.
Well, Jeff, I have a question. I have a question.
Yeah.
One more.
Yeah.
Okay, so 6.3, 164 number.
What number?
164.
164.
Yeah, 164.
Oh shoot, where am I? Stuff got all out of order. There we go. The one about Christopher selling his dinette set? 164?
Yes, sir.
Okay.
6.3.
6.3.
6.3.
6.3.
Yes, sir. 164.
And what's yours say? Christopher sold his dinette set, that one, right?
Yeah. Yeah.
What do you mean your guess? What does your problem say? Say- Yes, but the first line says Christopher sold his dinette
Yeah,
set. Okay,
yeah.
okay.
I misunderstood.
Right.
Sorry.
That's right.
I know you're cracking up.
All right. Just want to make sure I'm talking about the same problem you got a problem with. So Christopher sold his dinette set. We know that part. For $225 online, which charged him 9% of the selling price as commission. Got to spell commission. Oh, good. Yeah, how much was the commission? And again, that commission, I don't know if you've ever worked a sale job. Like a friend of mine worked in Circuit City. Circuit City is a good example of they just, they're on you. Do you need help? Remember me. Oh my God, get away. Because they make commission. So if you buy something and you're the one that helped them out, then you get a commission on what they buy. It's a lot of this incentive to really be extra hard salesman. Damn, D. I like it. You're riveting, Jeff. All right, so how do I figure out how much commission I had to pay then? Or Christopher has to pay. 9% of what? What was the selling price, Rick? What was the selling price? What did he sell it for?
$225.
$225. And they charged 9% of the selling price as commission. So, what's the selling price? What was the selling price again? You just told me.
Hang on, $225.
225. Can you do 9% of 225? Well, you can, but how do you do it? How do you take 9% of 225? So this is, yeah, 9% you write it as 0, 9.
Wrong side.
You only move the decimal twice.
Alright, makes sense, okay.
Times 225. So those problems are nice. They're not algebraic. They're purely computational. You just have to do a percentage of an amount, and you're done. Yeah. There's no formula to set up, nothing like that. Anything else from homework or somewhere else?
Probably
Probably.
170.
Okay.
Does it work the same way?
No.
No.
Did they tell you the percentage on 170?
No.
In fact, the question is, what's the rate?
Rate of acquisition.
Right? So if they earn $11,250 on the sale of a $375,000 house, that's obviously not La Jolla. Or maybe it's a garage in La Jolla. A quarter of a garage. So watch this. How much did the site make on this dude? How much did the site make off of this dude? 9% of 225, whatever that is. 20 bucks, whatever. Sure. Right? So this is 2025, right?
I think so.
So that's the amount. That's the commission amount, right? And I could figure it out because I knew the rate. Now, if I know how much commission I make, and I know how much the selling price was, I can divide those two to figure out the rate, right? So rate is almost always a part divided by a whole. Right? So that's the selling price. Out of that selling price, how much did he make commission? And now you can divide that and make it into a decimal and make it into a percentage. So look at this. I can make an equation out of this. Percentage times selling price equals commission. You guys see that? Percentage times selling price equals commission. So if I don't know the percentage, I just divide this over here, divide the commission by the selling price, and then I can get the percentage. I can get the rate. So there's other problems here like tax rate. If I paid $8 tax on something that cost, what you got, Jeff? I don't know, Jeff, leave me alone. $102. What was the tax rate? How do I figure out the tax rate? What would I do? I pay $8 tax on a $102 item. What was the tax rate? How do I find that? The only operation that I didn't hear anybody say. Divide. So $8 tax out of a $102 item. I divide to see what the rate is. A rate is always going to be some kind of division, because what's rate mean? Something per something else. So if it's an 8% tax, that's
What is that?
on a $102 item. What? Yeah. Do you guys? So all right. Yeah. Keep on listening. So if there are 11 people that are left-handed out of 87 people, what percentage of the people were left-handed? How do you figure it out? Don't just do it and give me a number. Tell me how you figure it out. How do you figure that out? Yes, 11 out of 87. You have a part divided by a whole. 11 divided by 87. So tax rate works the same way. Commission rate works the same way. Rates in general are going to be some kind of division. Because what's rate mean? Something per something. Some ratio of two things. Okay. All right. Anything else from homework or quiz or anything? You guys look oppressed. That's good. Doing my job. No, my job is not to oppress you. Okay, we have one section left to do. Let's go back. Last time we did section 6.4. Let's try some problems out of the homework for 6.4. Yeah, so the formula for 6.4 is this simple interest formula. Okay, so this, what does I stand for?
Interest.
Interest, it's crazy. What does the P stand for? Principal. I think it's LE, right? Or I forget it, AL or LE. Okay, okay. What's the R stand for? Rate. And that's the interest rate. And what's the T stand for? Time. In years. So this is my simple interest. If I put $1,000 in the bank for a year at 5% interest, I should make interest 5% of 1,000 at the end of 1 year. If I put it in for 2 years, I'll make double that. So forth. If I'm using the simple interest formula. So let's take a problem right out of the homework. Let's see. Casey put $1,450. Yes.
It is BAL.
Is it AL?
Yes.
All right. Changes everything. All right. Put $1,450 in a 4% account for 2 years. Now this is just laying the groundwork for more advanced interest formulas you're going to learn in future classes. But right now this is purely plug and check. This is purely just plug things in the right place. So what's this 1450 variable wise? What letter is it going to be? 1450. Some of you guys might be like, what the hell is it? We know how to spell it now, but what the hell is principal? Was the amount you put into an account. Well, that makes it really clear. What's the 1450 going to be? No way. Right. So that's P. 4%. So R is going to be equal to what? 0.04. 2 years is going to be
Time.
2 years. It equals 2. Right? This is not one of those weird sci-fi movies where you actually can put years on your life or something. So that's not going to be my interest. That's my time. I'm going to put it in there for 2 years. What I don't know is what the interest is going to be. How much money will I have at the end of 2 years? So now it's just plug and chug. Right? So if I want to know what the interest is, it's principal, 1450, times rate, 0.04, times time, 2.
So you just plug it in?
Yeah. Was it? By the time the calculator caught up.
I don't know.
Oh. Sorry, I'm not laughing at you, just laughing at you.
So Jeff, you have to multiply 3 numbers, right? Okay.
So I think this section is almost too easy for you to believe. You have one equation for this section. It's just an example of a really basic use of percentages. And that's why they put it here. You can build off of this though, and I know some of you guys have been in the real world for a while, so you know that there's compounding interest and all this kind of stuff. That comes later, because the math behind that is just a little bit more involved. So believe it or not, that's what the homework is like for section 6.4. It's just plugging the right stuff in the right place. He's like, I'll believe it when I do it. All right. Oh, let me ask you this. They do a little bit of evilness to you. Yeah, let me see. Oh, here. That's nice. So they start off nice, and then they get a little bit more evil. Bless you.
Bless you. Thank you.
Yeah, okay. So if yes.
I know.
All right, let me make one more problem. Now here's as hard as these get. I'm about to do a problem that's the hardest this gets. What if I put $80,000 in a 12% account for 4 months. And here's my formula again. What's P equal here? 80,000. What's R equal? So tell me better. 0.12. I like it. R is 0.12. You never put the percentage number in there because the percentage number is not an actual number. It's a problem that has to be worked out. Divide by 100. Now, what's T? It ain't 4. I'll tell you that right now. If I put it in there for 4 seconds, here it is, put it in there, now I'll take it back. And then no matter what, no matter 4, it doesn't matter. I'm going to get the same amount of money always. That doesn't make any sense. T has got to be in
3 years. Is it 3 or 30?
It's got to be in years. So right now, I'm sure some guys are like, well, it's freaking 4 months. It's not even a year. It was a part of a year, ain't it? A year is how long in months? 12. So what part of a year is this? 4 months out of 12. So time will be 4/12. 4 months is 1/3 of a year because 1/3 of 12 is 4. So you should have known T was going to be a fractional anytime they give you months. You can figure out what that fraction is. You can always just put that over 12.
Would you be wrong if you...
No, you'd be right. 1/3, 11. 1/3. If you do 0.333, you're automatically going to be wrong because you've rounded. 1/3 is 0.3 forever. I don't have time for that. Yeah.
It's like weeks.
All right. So how many weeks roughly in a year? 52. Do you know that? 52 weeks in a year. So if it was for 7 weeks, then you say 7 out of 52.
So you always count it over the year.
But I think they only go to months. Yeah. So whatever unit they give you, you got to relate it to the full year's worth of that unit. So if it's months, a full year is 12 months. If it's weeks, a full year is 52 weeks. If it's days, what's a full year? 364. 5 almost. 364. Okay. All right.
I don't know.
Depending on if it's a leap year or not. So, how do I do this? This isn't too bad. Don't make this 0.3. There's no reason. Because the interest will be 80,000 times 0.12 times 1/3. You just put all that in your calculator. So in here, so instead of doing times 1/3, you could do divided by 3. It's the same thing. If you want to.
Can you cancel it or does it go over?
Yeah, you could if you want to. Just do it correctly. So 3 goes into 12. 0.12.
4.
So what would you actually put here?
0.4.
0.04. So see, that's why I say don't do that to yourself. Why? It is a decimal, right? So you can't just put a 4 there. 0.12 divided by 3 can't get bigger. It's got to get smaller. So just throw that all in your calculator. You should end up with 3,200, I think? Yeah. 3,200 bucks. So that's the one thing to be careful on in that section is the T has got to be in years. So if I said 7 months, T would be 7 out of 12. Just put it out of whatever the total year number would be. Maybe. Oh, you guys, I'm so excited. If I were you, I would love this section. Just plug and chug. Yes. Good? Okay. All right, guys. One last section in chapter 6 here. And this deals with using proportions So let me start off with a real world application of this. If you're using a map is normally where this happens. On the map.
Swipe or no swipe?
On a map, you'll see something like 1 mile is 3. Let's say 3 inches. A very zoomed in map. See what I mean? Yeah. So on Google Maps, if you zoom in, the scale is always there. You can actually watch the scale change as you zoom in. I like it. So 1 mile is represented by 3 inches. So if two towns are 7.7 inches apart on the map, how far apart are they in real life? So what can I set up right here that we've been working with? What can I set up right here? 1 mile is to 3 inches. What can I set up right there? Just like 8 bananas is to... Yes. So I can set up a ratio. So 1 mile to 3 inches. So if two towns were 2 miles apart, how far apart would they be on the map? If I had something that was 2 miles apart, they would be 6 inches apart on the map. You guys see that? That's the physical interpretation of building a fraction up. So if it was 3 miles apart, it'd be 9 and so forth. But what do I want to have happen? What do I know in this next question? What do I know for sure? What do I already know for a fact? The towns are 7.7 inches apart. What I don't know is how many miles apart they are in real life. So this is what's called a proportion. A proportion is a special name for making two ratios equal each other. So when I have a ratio equals a ratio. Why did I put the X on the top? But why did I put it on the top? Why didn't I put the X on the bottom? Because what is it that I don't know? Right. I don't know miles. I don't know the miles in real life, right? Stay with me now. Where did I put the miles here? Top. So this better be on the top also, or else it don't make a damn bit of sense. So if I had... I'm sorry, D, what's up?
What you do to one side?
That's true. That sort of builds into this. So if I saw on the map something was 12 inches apart, how many miles apart would it be? Do I really have to do a lot of work here? If it was 12 inches apart on the map, how many miles apart would that be? 4. Exactly. You guys see that? So all this is saying is this ratio has to stay the same no matter what happens. I gave you an ugly number, so I'd much rather set up the algebra and then just attack it with algebra. Let the algebra worry about the decimal, right? If I give you this, you can just go, that's times 4. This has got to be times 4 miles. Done. Next one, Jeff. Because 12 and 3 work well together. 7.7 and 3, they don't like each other. So how do I do this algebraically now? How do I solve something like this? 1 over 3 equals x over 7.7. Yeah, have we talked about cross multiplication yet? I always get... Haven't we done this already? Let's see. So here's the equation we're working with. 1 mile to 3 inches equals x miles to 7.7 inches. So this is exactly the only time you can just directly do cross multiplication, is when I have a fraction equals a fraction. Students try to do it in all these other places. No. So what some of you guys might realize I don't really have to fully cross multiply, but let me just do it, and you can pick up on shortcuts later. So I do 7.7 times 1 and 3 times x. Is that cool?
Yep.
So I get 7.7 equals 3x. And then how do I solve for x? Divide by 3. I love it. Divide by 3. Divide by 3, I get x equals whatever the hell.
1.1.
It's not a bad first guess, maybe, but we can do better than that.
2.56.
2 miles.
Yeah, so 2, it's going to be at least 2, right? 2 times 3 is 6.
Yeah.
2.56, sure. 2.56 what?
66.
No.
X.
Miles. Yes. Oh shit, here come the units again. Miles Davis, I like it. Work Miles Davis into a math class, I like that. You know I'm gonna, if you just say 2.56, I'm gonna say what the hell? I'm gonna say bananas. I'm gonna do my dorky thing. So don't let me do that. Please put something there. Don't give me room to play with. Alright, let's do another one. Here, you guys try this one, you ready? Write this down. 1 12-ounce can of soda has 150 calories. I love the names nowadays and the math problems. You guys got me? 1 12-ounce can of soda has 150 calories. If Josiah drinks the big 32-ounce size from the local mini mart, how many calories does he get? So 1 12-ounce can of soda has 150 calories. Josiah drinks a 32-ounce size drink. How many calories does he get?